October 24th will witness NASA launching something it has never launched before, the first ever spacecraft to go and seek actual signs of life on another planet. NASA has anticipated this launch since 1989, and the long-term plans are finally becoming a reality, with news headlines blowing up, the views skyrocketing, and more questions being asked than we could possibly answer. Let's tackle as many as we can. Why is NASA so eager to fly back to Europa? And what does it have to do with the old Galileo mission, which flew to Jupiter, Europa's mother planet? The story is an interesting one, so let's consider one important aspect after another. The space technician. Signing on. Back in 1989, NASA launched Galileo, a satellite that orbited Jupiter for years. Since then, it has collected a lot of data that it fed back to Earth. This data showed something strange, previously thought impossible. It showed minor fluctuations in Jupiter's magnetic field in the vicinity of Europa, its fourth largest moon. The fluctuations could mean only one thing: that there was liquid water on the moon. Surprised, scientists gulped down on the sporadic information, but they needed to collect more. 35 years later, they finally have a chance to do so with a new satellite, the Europa Clipper. The satellite holds some of the most advanced technology available at NASA and is set to launch in October this year. And while some may say that NASA is looking for life, others may be more cautious. Both are certain to be correct, up to a degree. NASA plans to do several things with the satellite, therefore all the equipment on board. But what it is exactly looking for is the question we will be answering. First things first, the satellite will be traveling some 630 million kilometers away from Earth, and this means around 5 times less sunlight to power its electronics. This means that the Europa Clipper will need huge solar panels, so big that the satellite will be more than 30 meters wide with its array deployed. The solar panels will be powering 2 8-megapixel cameras that the satellite will use to take high-res photos of the surface of the planet. They will also power thermal emissions imaging systems or infrared cameras that should observe the planet and see where the warm water is closest to its icy surface. Another set of spectrographs and spectrometers will try to determine the composition of the atmosphere and the composition of ice, salts found on the planet, and possible presence of organic materials. The magnetometer on board will study the moon's magnetic field and will try to determine if there really is an ocean, as well as the thickness of the ice sheet. Another instrument used for magnetic sounding will be exploring more details on the oceans and their composition. The radar and gravity instruments will then observe the fluctuations in the moon's gravity to determine its internal structure. Besides these, there will also be instruments for chemical analysis of bits and pieces that can be found in the planet's orbit. However, let's take a look at what the satellite will be dealing with mission-wise. As always, the first thing to consider is the water on Jupiter's moon itself. The watery world on Europa may not be something you expect. Namely, the moon is 5 times more distant from the sun than the Earth is. So the whole moon's surface is likely to look more like Earth's polar caps than the rich tropical seas that harbor immense life diversity. As there is very little light and energy so far away, it's no surprise that the scientists back in the 1990s were so surprised with Galileo's findings. The satellite worked well, but the data was confusing, until the scientists gave it a second thought. There must be some underlying processes that keep the water in a liquid state, and indeed, the findings of liquid water came from the depths of Europa's frozen oceans, deeper than 30 kilometers or 20 miles to be exact. The processes that keep the water liquid and warm so deep had to be geological in nature. Just like on Earth, the hot core maintains some geothermal vents active, and they keep the water warm. However, running simulations proved that Europa's core is simply not warm enough to keep all this water warm. So there had to be something else at play. Something making the difference between a planet that could potentially harbor life and a frozen hell, stuck in eternal ice age. While ice does provide insulation, The insulating effect and the geothermal vents are simply not enough. And then it dawned on them. The moon is subject to strong gravitational pull, both from Jupiter and its satellites. This pull is so strong, it could bend the ice on the planet's surface, and its rocky surface as well, in a tidal motion that causes tide and ebb on Earth. This could cause enough friction to ensure that the water stays warm. But exploring Europa's oceans and how warm they are is not the only reason why NASA wants to go back so badly to this Jovian moon. Although liquid water is necessary for life, it is impossible that this is the sole reason to be headed back to a moon 628 million kilometers or 400 million miles away from Earth. To get the bigger picture, let's consider the ice on its surface again, and the radiation it has been bathed in for millions of years. It is this radiation that carries enough energy to break down the water molecules in the ice into hydrogen and oxygen. And while hydrogen is so light it flows into space right away, the oxygen is just heavy enough to stay on the planet and potentially seep into the ocean below through holes and crevices. And this is where the magic begins. Oxygen is extremely reactive. So reactive, in fact, that it is considered one of the biosignatures on distant planets and their natural satellites. So reactive, in fact, that it could react with some other elements in Europa's ocean to possibly form organic compounds. Or is it? Life takes immense amounts of energy to form and sustain itself, so immense that it takes the sun to keep life on Earth living. Europa is simply too distant for this level of energy received. And even if it wasn't, the 30-kilometer or 20-mile ice sheet of ice is sure to prevent any light from reaching its oceans. So, what could possibly be happening in this distant world? To better understand what could be happening underneath Europa's surface, we have to dive deeper under our own ocean's surface. Back on Earth, it wasn't until the 1960s that the first life forms were detected where it was previously thought impossible to find life. At the bottom of the Mariana Trench, a place of complete darkness and incredible pressure, the trench was thought impossible to harbor life. But this was wrong. The trench is teeming with life, at places reaching life form diversity comparable to that of rainforests on land. It is geothermal vents scientists were fast to notice that provide energy and minerals that life needs to sustain itself. And this could be the exact process that is happening deep in Europa. The tidal forces, the warm core, and the radiation from the split oxygen from the surface may combine enough energy to sustain life. On top of this, for now, there is no need to doubt that the geothermal vents on Europa do not spew out minerals, just as those on Earth do. And the sheer limit of the elements available dictate that at least some of these could be conducive to life. That being said, it is clear that NASA has some good reasons to go back to Europa for more research. But is this the only thing that NASA is interested in? NASA's webpage dedicated to the satellite says that it will be determining the thickness of the ice shell on the moon, investigating the composition of Europa's oceans, and studying how the surface has formed. As simple freezing may not be enough to explain all the fault lines in the ice and a surprisingly low number of craters on the surface of it. However, all this is suspicious. NASA is always investigating distant planets, but spending $5 billion on a single spacecraft to investigate the thickness of the ice sheet seems like a lot. The same goes for oxygen presence, especially as this can also be done remotely from Earth in some cases. Maybe NASA just went over budget again. But the total composition of the planet is a good thing to know, but in its own right may not be important enough to help justify the funding. The combination of the three, however, may signal what the odds are of finding life on Europa, and may be a good starting point for future missions to this and other of Jupiter's moons. After all, NASA has been on the lookout for extraterrestrials for a long time now, and seems to know what it's doing in searching for planets with biosignatures and those that may support life. After all, Europa Clipper is not going to be sent that far away and crashed in the process just to collect data in a dead-end mission. NASA simply knows better, and so do we. In the meantime, the information on the ocean under all that ice, the composition of it, and possible contents of oxygen in the water itself, as well as the presence of geothermal vents, could hint that future missions are needed and encouraged to get to the bottom of the habitability of this planet. What do you think is the likelihood we find life or another habitable planet this close to our own? How different do you think life on this moon would be from life on Earth? This is the Space Technician signing off for now, and I'll see you, Space Cowboys, in the next one.